Hello, and welcome to this training on the Envision language on the topic of working with dates. This training assumes some familiarity with the language itself, but will otherwise examine those features from scratch. To begin, I have loaded a file that contains all the holidays in France for the last 20 years. In this file, I expect to find one column, and this column contains all the holidays. So a date will appear in this column if it is a holiday, and it will not appear if it is not a holiday. To load this, I will use the date type. The date type in Envision is used to represent a combination of a year, a month, and a date. For instance, 2020, 12, 25. We support dates starting on the 1st January 2001, and we recommend not going beyond the end of the century. Envision provides many useful functions for working with dates. For example, let's say we want to count the number of holidays in every year for the last 20 years. For this, we want to display, for instance, a bar chart. And in this bar chart, we will count the number of lines in the holidays table, and we will group them by the year of every holiday. The year function applies to dates, and for a date like 2020, 12, 25, it will return 2020. A similar function exists for extracting the month number, or 12 in this case. This function is called monthNum for month number. But what if we wanted to extract the month of December 2020, or 2020, 12? For this, we can no longer represent the results as a number, like the year or the month number were. Instead, we have a dedicated type, which is the type month, similar to the date type to represent a full date. And the month type is a combination of a year and a month within that year. And to extract the month of a date, we simply call the month function. In total, Envision defines 3 calendar types. One is the date type, 2020, 12, 25. Another is the month type, 2020, 12. And the third one is the week type, or 2020, W52. This is called the ISO week number. So the 25th of December 2020 falls within the 52nd week of the year 2020. Envision provides functions to create those dates from the components. For instance, the date function takes 3 arguments: 2020, the year, 12, the month, and 25, the day. The month function takes 2020, the year, and 12, the month. And the week function takes 2020, the year, and 52, the ISO week number. As I have shown before, Envision also provides functions for accessing the components of the dates. So we can extract the year using the year function applied to a date. This will return a number, 2020. And the month using the monthNum function. This will return 12. And the daynum, which returns 25. The same functions can also apply to month values. So the year is also extracted using the year function, but applied to the month type. And the month number using the monthNum function applied to the month type. For the week, it is a bit more complex. The ISO year is used. This is because a week, unlike a month, does not usually fall entirely within 1 year. Instead, the first and last weeks of a year usually overlap with the previous or the last years. And to make this distinction clear, the ISO year is referred to. This is the year that the week is intended to be a part of. And the week num is the week number within the ISO year. Envision also provides conversion functions between the calendar types. So for instance, we can go from a month to a date by using the date function. So xDate equals date of a month and a day within that month. And conversely, we can go to a month from a date using the month function. The same applies to weeks, using the date function with a week and the number of the day within that week. In this case, 4. 0 is for Monday, and 4 in this case is for Friday. And we can go from a date to a week using the week function. Let's talk now about date arithmetic, or the ability to add numbers to dates. So the next date, the day after a given day, is just the date plus 1. And the next month is the month plus 1, and the next week is the week plus 1. Using this as a building block, we can build more complex functions. For instance, what is the first day of the next month? We will need to call day on the next month, which is computed as month of x date plus 1. And then we take the first date of that. For convenience, Envision actually provides a function which is called month start, which is always the first day of a given month. Now, how do we compute the last day of a month? The last day of the current month would be, well, the start of the next month minus 1. But we also do have a function called month end of the month of the date. And for convenience, we also support calling month end and month start directly on a date without requiring a conversion to month first. Similarly, we can compute the Monday of a given week and also the Monday of the week that contains a given date, which for convenience can also be invoked on the date itself. This function can then be used to compute the day of the week, in this case x date minus Monday of x date will be 4, meaning Friday. Now let's go back to our holiday analysis. As you may know, in France we have a few holidays that move around during the year. So sometimes the month of June will have 0, 1, or 2 holidays inside it. To work with this, we will need the month num function. And to compute the average, well, we know that we have 20 years worth of data. So each month will appear exactly 20 times. And so we can just divide by 20. And this will give us the average number of holidays for each month. Of course, this is a very brittle way of doing things, because if we add 1 year, then the 20 will no longer be correct. And what happens if we have only partial data, not a full year? Then for some months we would need to divide by 20 and for others by 21. So let us approach this in a cleaner, more data-driven way. I will begin by saying that the initial approach has a flaw and will only be provided as an explanation. the general idea here is that since we want to compute an average, then we need to create a table that represents the data over which we want to compute the average. So in this case, it will be a table containing the months. Let's give it a primary dimension called M, and this is a group table based on the month of the holidays themselves. And this will contain one line for each month that appears in the holidays table. And if we want to construct the number of holidays within a month, we can just count the number of lines. So, given this amount, we can then average this. So, months dot holiday count, and we group by M, the month number, which converts 2020-12 to just 12. In theory, this should work. In practice, however, the months table here only contains months that have at least one holiday inside them, because it is built from the holidays table. So, for instance, in 2001, the month of June has one holiday. On the other hand, in 2002, the month of June is missing. There are no holidays in that month, and so it will not appear at all in the months table. This means that there are no zeros taken into account in this average at all. Now, if you have experience with other relational languages, such as SQL, you know that a typical solution to this problem is to define a table that contains all the dates in a given range, independently of the dates that actually appear in the dataset. And since Envision is designed to work with time data in the context of supply chain, it also provides a primitive for doing that. This primitive is the span date statement. Let us first define a start and end date for our span of data. So for now, I will just define them as constants. Date 20111 for the start date and 2020 1231 for the end date. The span date statement defines the range using two dates. And it opens a nested block where a new table called day with a primary dimension called date has been defined as containing one line for each date between start inclusive and end inclusive. This lets us define a value is holiday for every date in that range as date in holidays dot holiday. It also creates two helper tables so that we do not need to define month manually. In this case, it defines a table called month with a primary dimension called month as well, which is a grouping of month of dates, and a week table with a week primary dimension, which is a by week of dates. Those are automatically defined for us, so we do not need to define them ourselves. So in this case, month dot holiday count equals the count of day dot is holiday. And in this case here, on 20106 we do have the value 1, and on 20206 we have the value 0 instead of a missing value. And from that we can write our bar chart using month holiday count using month num of month. And to simplify this, we can also use a keep span so that no indentation is needed. There is another way to define the day table. This is done in the read statements by defining a secondary dimension date on the tables. So in this case, I would read the holiday column as date, and I would expect a date dimension here. And so the keep span is no longer needed. The fact that at least one table expects the secondary dimension date automatically creates the day, month, and week tables in that script. However, this is not exactly equivalent to the script we had before. The reason for this is that the range start and end, which is selected in this case, is based on the first and last date in the input tables. So in this case, the range would go from the very first day, so 1st of January, so this one would be the same, to the last holiday in 2020, which would actually be 25th. So the range is not exactly the same. Of course, the month table would remain the same since December 2020 would still be represented, but this can still create problems. For instance, so now is holiday, we compute this by saying, well, is there any line in holidays that corresponds to that date? This works because date is now a secondary dimension in holidays, so it is linked to the day table. And now let us also look at date.isWeekend. So this is computed by saying that the number of the week, which is date minus Monday of date, is greater than or equal to 5. So 5 is Saturday and 6 is Sunday. And now, instead of counting the number of holidays, we count the number of working days, which is a day that is not a holiday and is also not a weekend. And now, average working days per month, and we display working days. And now, this approach would be incorrect because the date range does not contain the last few days in the last December of the date range. So because of this, we still need to add the keep span. What happens here is that the expect date has already created the day, month, and week tables. So the keep span observes that the dimension it is affecting has already been created and works on top of it instead of creating a brand new one. In this case, it will check that this is actually an extension of the data. Meaning, well, if we went to 2025, then we would have dates that go beyond the end of this range. And so the keep span would report an error at runtime saying, I have found a date beyond the end. However, extending, so if all the dates previously in the day table are all within the new range, then it is safely extended. This extension also preserves all the secondary dimensions, because if a secondary dimension was previously correct, previously in the range, then since the range has been extended, it still contains all the previously available dates, and so that dimension is still safe. Because of this, if a holiday was in the holidays table, and this only extends the day table, then the holiday.date is still available. To protect against the 2025 problem, we will now define the start and end based on the minimum and the maximum of the date. And obviously this does not extend anything because it will still go from the first day to the last date. So we will go from year start of this minimum to the year end of the maximum. So this now covers the entire years for all the dates that are present in the input holiday table. Let's talk now about what happens when you leave the span. So in the case of a keep span, this will keep going forever, but if this was a span of dates, then any value defined in the day or month inside this will still be available outside them. Because if it is defined for all the dates in this range, and this range is larger than what it was before the span date statement, then those vectors are still available afterwards. And so I can show the bar chart outside of the span dates as long as I compute the working days inside it, and so take advantage of the full range for the weekend. Of course, there is not really a purpose of doing this here, so let's use keep span as such. Finally, there is actually something special about the month and week tables. At first, it does look like they were defined as grouping tables. However, unlike true grouping tables, they are not completely independent from the day table. What happens here is that whenever the day, month, or week table is filtered using a where statement, the other two will be filtered as well. So if I was to write, for instance, keep where date is smaller than date 2015 6/15. This would, of course, drop many lines from the day tables, but it would also drop all the months and all the weeks that do not contain at least one value in the surviving day table. This means that the day, month, and week are always kept in sync. Similarly, if I keep where month is greater than the month of 2010 5, all the days that were included in the dropped months will be dropped as well. And from there, all the weeks that contained only days that have been dropped will be dropped as well. In a way, the day, month, and week are actually all views of the same date range between a first date and a last date. It is also possible, although not recommended, to create holes in these. For instance, I could decide to drop all the first days of each month. Oops. In this case, we would have one hole at the beginning of each month. This would obviously not be enough to drop any month or any week, but it would create holes in the day table itself. And similarly, it is possible to drop entire months. For instance, where month num is February, the line is dropped. This concludes the training on dates in Envision. Of course, this is only a basic overview of those features, and there are in fact many other more advanced features which build on top of these. Those will be examined in a future training.